Okay, so this is video 4 of proofs. Remember, for proofs, you need to write out every single step in words and math notation. It'll say something like, prove that this equals this. Think of this x as your problem and this is your answer. You're not treating it like a normal equation. You don't ever add or subtract across your equal sign. For proofs, you need to be able to convert everything to sines and cosines and recognize some identities, specifically right now, the Pythagorean identity. Okay, and so our hints so far are to simplify, so distribute and combine like terms, or factor and cancel if you have a fraction. Convert everything to sines and cosines so that way you can look for identities. And then last video we talked about finding a common denominator if you're adding fractions, and this video will deal with dividing fractions. So if you have a fraction within a fraction. Alright, so let's start. For this one, show that tan theta over secant theta equals sine theta. If you look at your hints, the first thing that I would do would be convert to sines and cosines. So tan theta is the same thing as sine theta over cosine theta, and secant theta is 1 over cosine theta. Now, this is a fraction within a fraction. So our hint says keep, change, flip, and cancel. So what I mean is your original fraction bar is going to now be your division, and so you have this top fraction divided by this bottom fraction, and you can keep, change, flip. So keep your top fraction the same. Well, first let's see. It may help to rewrite as division, just in case you've never seen this before. So if I rewrite it as division, I'll have my top fraction divided by my bottom fraction. Okay, and now I can keep, change, flip. So keep your first fraction or your top fraction as it is. Change division to multiplying and flip your second fraction. And the point of that is when things are multiplied together in fractions, you can cancel only if they're multiplied. If they're added, you can't do it that way. But if I cancel these two, one's on top and one's on bottom, I can cancel, and then I'm left with just my sine theta, which is what I wanted to be left with. Perfect. Okay, let's do one that's a little more difficult, or more steps than this. Okay, so show that tan theta plus 1 over secant theta equals sine theta plus cosine theta. So the first thing I would do, again, there may be other first steps that are better, but I would convert to sines and cosines, because right now I have 4 different trig functions, and so I convert to just 2, then it'll help me cancel things out. Plus I'm trying to get to just sine and cosine, so if I convert this early, maybe I can see where I'm trying to go. So if I convert to sines and cosines, tan theta is sine theta over cosine theta, and my denominator secant theta is 1 over cosine theta. Okay, so 2 things stick out at me. I am adding to a fraction, and I have a fraction within a fraction. Before you deal with your fraction within a fraction, like we did last example, you have to have 1 fraction on top divided by 1 fraction on bottom. And right now I have an equation on top divided by a fraction. So deal with this first. So we can get a common denominator and write that top part as 1 fraction. Okay, so on top I have this sine theta over cosine theta plus 1. I'm just going to ignore the bottom. I'm just kind of leave it down there. We're not messing with it. Okay, so I can rewrite my 1 as 1 over 1. So now it's adding 2 fractions. They have to have the same denominator in order for you to add them together. So I need a cosine down here, and whatever you put in the bottom, you put in the top. So now this is sine theta over cosine theta plus cosine theta over cosine theta, or if I rewrite the top or the numerator, that's what I should say, as 1 fraction. Ignore this for now. Can't cover that with my finger. Okay, so if I rewrite the numerator as 1 fraction, you add across the top. So I'll have my sine theta plus cosine theta, and I write the common denominator only once. There we go. And now just keep your bottom piece that we've been dealing with, or just kind of been bringing along the whole time. Now, this is good, because now I have 1 fraction divided by 1 fraction. If it helps, you need to rewrite as division, you can. So I'll have the top fraction divided by the bottom fraction. And now keep, change, flip. So keep your top fraction or your first fraction, change division to multiplying, and flip your second fraction. And now, as long as it's multiplied, like here, this cosine is multiplied by this whole piece here, I can cancel this with a cosine in the bottom, and I'm left with just sine theta plus cosine theta, which is what I wanted to get. Perfect. All right, and then last one like this, let's do one that's a little bit harder, or more steps. So this time, 1 plus tan theta over 1 plus cotan theta equals secant theta over cosecant theta. Again, my first step would be to convert everything to sines and cosines, because right now I have 4 different trig functions, and it helps if I only have to deal with 2. Plus, all of my identities I can convert to sines and cosines, all of my trig functions, so deal with that, and then I can convert back if I need to. All right, so that means on top, tan theta is the same thing as sine theta over cosine theta, and on bottom, cotan theta is the same thing as cosine theta over sine theta. 2 things should jump out at you. We're adding fractions, and then we also have a fraction within a fraction. But it's not just 1 fraction divided by 1 fraction, it's an equation over an equation. So that means I have to find common denominators on the top and then find a common denominator on the bottom. All right, let's just deal with the top for a minute. Okay, so if I just look at the top, ignore this piece right here, I'll just kind of cover it up with a pencil. I can rewrite my 1 as 1 over 1. They need to have the same denominator, so I need a cosine here, and whatever you put in the bottom, you put in the top. So that means in my numerator, my fraction would be cosine plus sine, cosine theta plus sine theta, all over, you just write your common denominator once. All right, now I'm going to do the exact same thing here, ignore all this, with the denominator. So my 1 plus cosine theta over sine theta, I can write this 1 as 1 over 1 and get a common denominator here. I have a sine here, so I need to put a sine theta here, and whatever you put in the bottom, put in the top. So this denominator, you add across the top, sine theta plus cosine theta, and you keep the common denominator only once. Okay, so this fraction turned into this fraction, which turned into a fraction over a fraction. 1 fraction divided by 1 fraction. This is good because if I need to, I can rewrite as division, and then I can keep, change, flip. If you see 1 fraction divided by 1 fraction, keep, change, flip so that hopefully things will cancel. Okay. Keep, change, flip. Keep your top fraction or your first fraction. Change division to multiplying and flip your second fraction. And then as long as things are multiplied together, you can cancel them out. So that means I'm not going to be canceling like this sign with this sign individually because this sign is added to the cosine. But this whole entire thing is multiplied and this whole entire thing is multiplied. So I can cancel this whole piece because it's just multiplied by sine, and this whole denominator here is just multiplied by cosine. And so I know they don't necessarily look the same, but if you just like side note think 1 plus 2, that's going to give you 3. And then 2 plus 1, well, that also gives you 3. So order doesn't really matter if you're adding or if you're just multiplying. I think that's called the commutative property from like 5th grade. So that means these two are the same thing. This is like your 1 plus 2, and this is your 2 plus 1. They're both the same thing. They're both 3. So I can cancel those two and be left with, a 1 over cosine theta times sine theta. Or you could write it as sine over cosine. I just know what's coming next, and it may help you to see it this way. All right, so next I need to get secant over cosecant. So right now that I just have it down as simple as I can get from sines and cosines, let's convert these using the reciprocal properties. 1 over cosine theta is just secant theta, and sine theta is 1 over cosecant theta. You don't have to do this step, but if you wanted to, you can rewrite this as one fraction. Secant times 1 over cosecant is just secant theta over cosecant theta, which is what we're trying to get. And so now we're done.